Okay, hi everybody. So here's another video where we look at an example of some difference of squares factoring. So I'm looking at the expression I've got here. I see two terms with a subtraction in between. That's awesome. I know I can make that into a difference of squares. And I notice that my first term, x to the fourth, that is a perfect square, and so is 1. So that actually makes this a little bit easy to work with. So I'm going to pop those down there. I know I'm going to get two binomials here. The square root of x to the fourth is going to be x squared, and then minus, plus, and the square root of 1 is just 1. So it's a really simple one to work with here. But the trick with this question here is now that I'm done, I need to look at my factors now and take one extra little look here. Did I create another difference of squares here? And the answer is yes, I did. Now, not that second factor, not that x squared plus 1. That's a sum of squares. And that I'm not going to be able to factor, not nicely using real values here. But this x squared minus 1, two terms with subtraction in between, yep, I can turn that into a difference of squares. Now, I've still got this x squared plus 1. That was kind of a dead end, so that's going to sit there like that. But here, the square root of x squared is going to be x. Okay? Now, I'm going to put subtraction, put addition, and then the square root of 1 is just going to be 1. And there you go. So this is going to factor down to x minus 1, x plus 1, multiplied by x squared plus 1. Now, that is as far as we teachers typically want you to go. But I want you to be aware, I'm going to draw a little line here. I want you to be aware that it is possible to push this a little bit further if you need to. And in a course like a calculus course, every once in a while you're going to bump into a problem here where actually it does help to see that this can go a little bit further here. Notice in this x minus 1 factor, I have got subtraction and I've got two terms. Well, I can actually force that to become a difference of squares. Now, I've still got this x plus 1. That isn't a difference of squares. I've got the x squared plus 1. That is not a difference of squares. But here, I can take that x and then force it to follow the pattern that I'm looking for by simply taking the square root of it. Now, it's not a nice square root, but I can do that. Make this subtraction and addition, and then I can break 1 down. Again, if its square root will be 1 and 1. Now, if you see how it's possible for me to do that, you probably can recognize right away, well, oh boy, can't I keep doing that kind of ad nauseum with this x root x minus 1? Couldn't I make this root x minus 1 multiplied by root x plus 1? And the answer is yes. Yes, you could. That's typically not very useful, though. Even what I did right here isn't always very useful, but there are situations where it does pop up. So I just want you to be aware that this is a possibility. This is possible. This is typically right here. This is where we want you to stop.